I have a talk that might, I don't know, go for an hour or so, maybe an hour and a half, but you will probably all fall asleep if you just listen to it. So I would like to encourage you to ask questions and challenge me and tell me, you know, I'm crazy or whatever you want. That's okay. And so if you anytime want to, you know, have some quick questions in here or something like that, that would be fine. That will make it more interesting. So let's start out with the question of what is Lean? How many here have run into Lean in any other place besides software? 1, 2, 3, 4. Okay, so a bunch of you know what Lean is. I've heard it said that Lean is to deliver constantly increasing customer value for constantly decreasing effort. Now, constantly decreasing effort does not mean fewer people. It means doing less stuff that does not deliver customer value and spending that same time delivering stuff that delivers more customer value in the shortest possible time frame with the highest possible quality. And since this is an ongoing thing, it's a journey. It's not a destination. It's something you do no matter where you are. You can always get better. So Lean, the term, actually has its roots in the Toyota production system that came before it in the 50s and 60s, when Toyota was learning how to make cars as productively as Detroit, but they couldn't make as many cars as Detroit. So Detroit's idea of making great big batches of fenders and great big batches of doors and stuff like that didn't work. So they came up with a different way of doing production. It was such a weird way that they called it the Ono system when T.E.G. Ono invented it, because they didn't think it would work. But it did work, actually. And in about 1970, it became called the Toyota production system. So this isn't about development at the moment, it's about production. And from that came something that was called just-in-time manufacturing. In the 1980s, I was involved in a manufacturing plant that started up doing some just-in-time manufacturing, and we were actually quite successful doing it. And throughout the 80s and early to mid-90s, lean manufacturing, or just-in-time manufacturing, was very popular in both Europe and in the US. And then, in 1991, a book was published called The Machine That Changed the World, The Story of Lean Production by Womack, Jones, and Roos. And that book sort of changed the name from just-in-time to Lean. So there's where its title came from. And while people were doing Lean, they also realized that Lean only works in the manufacturing plant, but if you go outside the edges of the manufacturing plant to one side or the other, then you come upon, you know, suppliers and customers. And as Lean became expanded to both sides, it started to be called supply chain management. And many efficiencies came from some good supply chain management. And in general, lean logistics became quite popular in warehouses, retail stores, even military organizations. And it's recently expanded to other operational areas, like hospitals, for instance, very often have lean programs. So that's production and operations and that sort of thing. But we don't do that. We do development. So what about development? Well, in the 1990s, mid to late 90s, people started saying, you know, if Toyota does these rather strange, unique, and effective things in production, what do they do for developing cars? How do they think when they develop cars? And so the Toyota product development system was studied, and a lot was published about it in the, say, 1998, 9, 2000 timeframe. And from that, we have a whole branch of people that write about lean product development. One of them, Alan Ward. You'll see I have a quote here and there from. And I think of lean software development as a subset of lean product development. It's a kind of a product that you develop with software. In fact, I think it's a really good idea to think of software as a product instead of thinking of it as a project. So the Toyota production system had some underlying principles, ways you think about things. And when I first started thinking about how, see, I was in a manufacturing plant and I did just-in-time stuff. And then I saw a really bad case of software development applied in a government project, and I said, myself, if only we could apply those same principles that I applied in the manufacturing plant, the software, what would it look like? And it came up with some principles. These are the ones I'm going to talk to you about today. There are 8 of them. One is eliminate waste. One is build quality in. One is defer commitment and deliver fast. Focus on learning. Improve relentlessly. Respect people and optimize the whole. So that would be a summary of what Lean is all about. Let's go to the big one, which is eliminate waste. The thing about waste is that it doesn't mean quite exactly what you might think. In Lean, waste is anything that doesn't add customer value. It's effort that you put out that customers don't appreciate. And when you need to get more productive, that's the best way to figure out how to do it, is not to say how fewer people can we do, but how can we make sure that every single person who's contributing an effort is contributing to something customers care about. Then you can create more customer delight and, preferably more customers. So one of the most important things about Lean, in order to make it successful, is you have to learn how to see waste. Because waste is something many people are blind to. And those of you who are involved in Agile, most of the stuff sounds like a good idea, but even in some of the Agile things, there's some waste, which I'll kind of point out as we go along. Okay, so learning how to see waste. Because waste is anything that depletes resources of time, effort, space, or money without adding customer value. Okay? So if you do something, spend time, effort, space, or money, and customers don't care, it's not doing anything for them, then that's the definition of waste. Now, some of that waste has to happen, and a whole bunch of it actually, if you thought hard about it, doesn't have to happen. You just kind of think it has to happen. So the other thing is, who's a customer? That's always a difficult problem, because stuff could happen to be subcontracting to somebody else. Who really is the customer? So value is seen through the eyes of people who pay for, people who use, people who support, or people who derive value from the systems we create. And that's not just the software, it's the whole system of which software is a part. Those people who pay for, use, support, or derive value from our systems, those are our customers. So for any piece of software, you actually have an array of customers to think about. And the thing that you have to do with waste is say, you don't get to define waste. It's your customers who get to decide what is waste and what is not. So you have to learn how to see the world through your customer's eyes, not through the way you are biased to looking at the world. So I'll throw a few wastes out at you, okay? The first one, and this really goes right along with in the Toyota production system, the biggest waste was making too much stuff. And guess what? The biggest waste, I think, in software development is making too much stuff. Because the problem is that when we make too much stuff, we increase the complexity of the system, and the complexity of the system will drive up the cost, not just linearly, but exponentially. So people took a look around at custom software development some years ago and said, what, do we really need all these features in this system? So think about the systems you work with. Are the features that are in that system stuff that people really need, use all the time? Or is there a whole bunch of stuff that doesn't need to be there? So in some studies, it was looking like maybe 2/3 of the features were seldom never used. Not safety features, but stuff that never needed to be there in the first place. And maybe only 20% of the stuff was always or often used. Now, let me ask you, does this feel, how many say, maybe it's not 2/3, but there's a whole bunch of features in my systems that don't need to be there? 2, 3, 4, 5, half of you. And all the rest of you, all of our features really have to be there, right? Wrong.